Now let's analyze velocity time graph. Is a topic that usually come in past questions, both WAEC, JAMB, GCE. So now, when you talk about velocity time graph, this is a graph that we use to plot what velocity against time. Velocity will be on the y-axis, or you say on the vertical axis, while time will be on the horizontal axis. Velocity, the unit for velocity is meter per second. The unit for time is seconds. So let's analyze our velocity time graph. Remember, graph always have four axes. Graph always have a graph always have two axes, but that two axes will divide it into four quadrants or four parts. Hmm? So velocity time graph falls on the first quadrant. This we here where everything is positive. So now the first graph you see here is a graph that represents a motion of a body that has a constant velocity. So as you can see here from the origin O, you see that the as the time keep increasing, like 1 second, 1 second, 2 second, 3 second, the velocity is not increasing. That the velocity is not going up or coming down. The velocity is still there. So this first graph here represents a graph with a constant velocity, and when you have a constant velocity, that means your acceleration equals to zero. Reason being that acceleration is what? Change in velocity over change in time. But here you see that the velocity that's on the vertical axis, the velocity is not increasing and it's not decreasing. So the velocity there is zero. The change in velocity there is zero over time. So whatever the time is, anything zero divided by anything will give you what? Zero. So when you see a velocity time graph where the vertical axis doesn't vary, you just have a straight line like this. That means that first one represents what we call acceleration is zero. So if the velocity is constant, the acceleration will be what? The acceleration will be zero. So and you see that this line has no inclination. This line has what? It doesn't have what? Inclination. That means the slope of this line is zero. Remember how we always calculate slope from our mathematics? Slope, or you say gradient. Slope equals to what? Change in the vertical axis, change in y, but in this case, our y is v. Change in v over change in t. And then you see that our v is not changing. Take for instance, if this point A here was 5 meter per second, you see that this place doesn't change from that 5 meter per second. It still remains there. So it will be, so at the time t equals to 1, it was 5 meter per second. At the time t equals to 3, it's still what? 5 meter per second. So we have to calculate the slope of this line, which will be 0. Our initial time was, okay, let's start from our initial time is 0 and our final time is 3. So that would be 3. Sorry. Me. So our initial velocity here is 5. And then at a time 0, initial velocity is 5. At a time t equals to 3 seconds, our final velocity is still 5. So that would be 5 minus 5 over initial time was 0, our final time was 3, 3 minus 0. So that would be 0 over 3 to give you what? 0. So if you calculate the slope will still give you 0. And the slope of a velocity time graph represents what? Acceleration. So the slope or gradient, of a velocity time graph represents what? Acceleration. represents acceleration. So for this first graph here, since the velocity is not changing, since the velocity is not changing, that means the acceleration is zero. So let's move to the next graph. Now, if you see this second graph here, you see that as the time is increasing, the velocity is also increasing. As the time is increasing, the velocity is also what? Increasing. So at any point in time where the time is increasing, the velocity is also increasing. So here you have your V1, you have your V2, here you have your T1, and you have your T2. So you see what happens here is what we call what? Acceleration. So that means this graph represents the motion of a body that is under what? Acceleration. That the body is accelerating. That's it. It's changing velocity as time is changing. So this graph here represents acceleration of a body. It represents what? Acceleration. Because here acceleration exists because there is change in velocity. And you know that the slope of this graph, which represents what? Acceleration, will be equals to what? V2 minus V1 over T2 minus T1. And assuming our T1 was 1 and our T2 was 3, and then our V1 was 2, while our V2 was 5. The slope there, if you calculate it, which is the acceleration, will be what? V2 minus V1. That will be 5 minus 2 divided by 3 minus 1, which is 3 over 2 meter per second. So you see that this graph has what we call acceleration. So this graph represents motion of a body under what? Acceleration. This graph represents motion of a body under what? Acceleration. So that means the body is accelerating. So let's move to the third graph. So on this third graph, now this is an inverse graph. What do we mean by an inverse graph? An inverse graph means an inverse graph means hmm, an inverse graph means that as the time is increasing, or as the time is increasing, the velocity is decreasing. So you see that the velocity here starts from a high side, and then as the time is increasing, you find out that the velocity is decreasing. And like here, this point R here, you see that the velocity will be 0. You find out that the velocity will be 0. So what this means is what we call deceleration. 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 So that means as the time increases, the velocity is decreasing. So this is a point where the body comes to rest at point R. So we call it deceleration, or call it what? Negative acceleration. So assuming if we level point, this place is 0, and then this place is let's say 5. And then here R, our t here, let's say our t here is 3. If you calculate the acceleration there, or the slope means calculating the level of inclination of a line in a graph, or any point in a graph. So if you calculate the slope here, which represents acceleration, that which is v2. Our in v1 will be 0, our v2 is 5, so which is v2 minus v1, 5 minus 0. Sorry, right, the mistake there. Okay, so our v1 here, that's our initial, this thing will be 5, while our final, this thing is 0. As the time increases, the velocity is decreasing. See, the velocity the velocity is what is decreasing as the time increases. So in this case, our initial velocity is 5. Our final velocity is what? 0. So that will be 0 minus 5 divided by our initial time is 0. Our final time is 3. 3 minus 0. So what would that give us? Minus 5 over 3, which will give us a negative what? Acceleration, meter per second. So negative acceleration is termed deceleration. That means the body is decelerating. It's gradually coming to rest until when the final velocity now becomes 0. That means the body is not moving again. So now let's compile all the graph together and see what goes on. So now if you watch this one now, if we are being asked to analyze what happens in this graph, what happens in this graph is that from point 0 to point A, the body is under what? Acceleration. That means the body has accelerated. The body is what? Under acceleration. Then from point A to point B, that means the body has a constant velocity. That means the velocity from point A to point B, the velocity is not changing. So at that point A to point B means what? No acceleration or zero acceleration. So let me write here from 0 to A means what? Acceleration. Acceleration. And then from A to B means what? No acceleration. No acceleration, or you say what? Constant velocity. Constant velocity means zero acceleration. Then from B to C, or from B to R. From B to R means what? Deceleration. Or you call it negative acceleration, or you call it deceleration. So that means the body's acceleration is reducing gradually until it finally comes to rest. So that is how to analyze velocity time graph. So this is a combination of the three graphs that we've drawn so far. So now, what if you are being asked what the area or shape formed by a velocity time graph? What parameter does it represent? So now you see that on the on the vertical axis it represents what? Velocity. And then on the horizontal axis represents what? Time. So if you do velocity times time, what parameter will it give you? Velocity times time. Velocity times time will give you what? Distance. Velocity times time will give you what? Distance. Velocity is what? Displacement over time. And when I say displacement, I also mean distance. So velocity times time will give you what? Distance in this case. We don't call it displacement, we call it what? Distance. In this case, velocity means the body has both magnitude and direction. So here we are considering the magnitude. So the area formed by this graph represents what? The total distance covered by the body. The area under a velocity time graph represents total distance, and total distance Total distance covered by the body. So the area under the graph represents what total distance covered by the body. So take for instance the graph we have here. Like now we say what's the total distance covered by this body now. Now you what you first thing you check is what kind of shape do you have here? Because this is a trapezium shape. Sorry for that. This is a trapezium shape. And then for you to calculate the area of a trapezium, we remember the formula for area of a trapezium. Area of a trapezium A equals to what? A half a half of what? The two parallel lines. You know, a trapezium is a shape that has two of its opposite sides parallel, like A to B is parallel with O to R. So a half of what? AB AB plus OR times what? The height. So if you call this place E, so from AE will be the height. AE. So that's the formula for area of a trapezium. Formula for area of a. So if you are to calculate the total distance covered by a body in which you are to analyze it from a velocity time graph. That means if you like for instance if the shape here is a trapezium, what you use to calculate that total distance is the area of that trapezium. And area of a trapezium is what? A half of you open brackets this the sum of the two parallel lines then times the height of the trapezium. But if you don't feel comfortable as analyzing it from a trapezium point of view, you can segment this shape formed by the graph. If you segment it, you see the first portion here, you have a right angle triangle. The second portion here, you have a, a square, or it can be a rectangle. And then this day, you have a triangle here, a right angle triangle. So, still, the area or the total distance covered by the body can be given as what? The area of this first triangle plus the area of this square plus the area of this second triangle. But since this is a trapezium as one, you can also do area of a trapezium. So sometimes the kind of shape you get on a velocity time graph might not be only a trapezium, it might be only a triangle, it might be a kind of semicircle or something of such. So you also have to know the formula for a semicircle and the rest. So thank you. So um you can join our WhatsApp group and post question where we make available questions based on this topic or on this concept so that once you're able to answer enough questions from it, you see how conversant and then you understand the concept very well. Thank you.